Hello there, and welcome to our first video tutorial on pointers and reference variables. Now, for this video tutorial series, there are actually a few prerequisites, a few things that I expect people to know. Well, the first one of them is C++ programming language. Second is difference between compilation and running. That's and I'll be using Sublime Text for as a text editor for this video series. And yeah, the third thing is actually command prompt operations. Yeah, so right here include with std++.h using namespace std int main return 0 and right here cout hello world and it's the compilation stage and just ran simple. But what are pointers? So pointers, get a basic understanding of pointers. Let us assume this is the complete memory of your computer. This is allocated to this this program. Yeah. And right in this you have chunks. Like the moment you declare an integer variable, like this some memory is allotted to it. Let us say this much amount. Now for our convention, some standard convention I'm defining right now, which I'll be using for the rest of the video tutorials. And in case you do not know this convention, it can get tough to understand. I'll explain this convention to you right now. Yeah, that's it. Now, what happens is right here I'll put in the variable name. Let's say A, the size in bytes which the variable is occupying. Let's say 4 bytes. Here will be the and right here I'll have the value of the variable. Let's say 152. And right here is the location in the memory where the variable is stored. 0x72ffc48, just a random value I put. And yes, how do we actually get to this value? Let us say we have an integer variable a right here. I gave an example of an integer variable a which has a value of 152. We know this a now, we know this 152. How do we get to this 4? We get to this 4 by using this size of function, size of a. It's a standard function in C++. I'll compile it, I'll run it and see the use 4. That's how we come to know of this value 4. And how do we come to know this? 0x72ffc48. I said that's the memory address of a, or ampersand a. I recompile and run it. The actual memory address is 0x72FE4C. I said FFC48, it's FE4C. Just for this time, I'll remove this memory address and I'll put in the memory address which I have got. But I won't be doing this all the time because it's good stuff. 0x72FE4, 0x72FE4C. Now right in this memory address, there are two components. Yeah, one is 0x, one is 72FE4C. Well, this thing is the actual memory address, and right here 0x signifies that what comes ahead is a hexadecimal code. So in case you are aware of hexadecimal memory or hexadecimal numeric operations, you know if we add 4 to this, C, D, E, F, and it will be 0x72FE50. And I can even confirm it to you guys by using int. I know you understand nothing of this. Star P. In fact, P++, and there will be P. In case the location didn't change, well, it changed. So I'll print out P right here. And that's a difference of 4, you guys see. Anyways, for now we'll assume that this is the memory address allocated. Yeah. So the next thing that happens is we'll understand what happens when we actually call a function. This is the function call. What happens right then? And what happens is that another chunk of memory is allocated like this, and just to keep it same as our standard rotation. Why did I make this box separate? It's in only in this scope. And this thing. Let us assume the parameter was named P. Again has a size of 4 bytes. It will have some different memory address. Let us say 0x72FFC8, and the value will be copied 158, 152, I'm sorry. And what happens now is any operation basically which we perform is performed right here on this memory, which is if we say P minus equals to 2, so P becomes 150 and this becomes 150, and the value of A still remains 152, which means our actual function is not changing at all. So I'll give it a better explanation in the next video, but thank you for watching and please subscribe to our channel.